from outside the cluster, from within the cluster, what are the enablements required to do that kind of networking, right? So there's service and ingress that are involved to do that, and we'll cover that in the third session today. In the last session, we'll talk about some advanced topics in Kubernetes networking, which is on how to do application layer network, what more features you can do for application layer networking in Kubernetes, followed by something that we at IBM Research are working on majorly is in the multi-cloud environment. We'll briefly touch upon what enables it or what's exciting there, right? So that's the agenda for today. It's majorly focused on networking today. Okay, so as yesterday, today's sessions will also be combined. That is, it will be some theory, some hands-on in all these sessions that we have today. So I think we are ready to get started. Yes? Yes. Good. So, okay, so the first thing we start today is container networking. Oh, yeah, just okay. So, in this session we'll talk about Docker container to container networking, how the Docker networking works. After that, we'll give you a feel of what was easily done by the Docker network by creating the network of your own, right? So we'll get a feel of what was made easy for us using Docker network and create our own network by ourselves on the Linux kernel, right? That's the agenda for the first session, right? So before starting, what is a switch? What is a normal network switch? Can somebody answer that?
So it basically takes a message and forwards it to all the hosts that are connected to it and doesn't just let who it's intended to, but broadcast it across the network.
It connects multiple ports or machines that are connected to it, right? Good. So at what layer does it operate at? I mean, the answer is there here. Yes. Right. So it operates at layer 2 of the network stack. Yeah. Right. So what we want to see is how do our Docker containers talk to each other, right? How is the networking? When you created a network, when you created a Docker container, you didn't have to worry about how it got the IP address, how did it communicate with a second Docker container that came out, right? So how does this networking be possible, right? So this is what we'll cover today. So by default, there are 3 types of network that get created automatically when you when you install Docker on your machine, right? When you start Docker on your machine. So there are 3 kind of networks. First is the bridge network. That is, you have a software bridge or software switch running on your machine, which helps connect these containers together. We'll see in detail on this in the next slide. But there are other 2. There are other 2 ways of how networking works as well. So by default, these 3 networks, one is a bridge network, which we'll study now. The other is where you want to just test your code and just want to see if it's working fine or not. You don't want it to be connected to network at all, right? Because if it's some critical application, you don't want anyone to get access to it. You just want to test it. There's a default mode called, mode called none, where it doesn't get any IP address assigned to it, right? And there is another mode that we'll also see today, which is the host mode, right? So what's the difference between the 3 of them? One is none, which is very easy, it doesn't get the IP address assigned. The second one is a bridge network, where what you will have is what we'll cover in the next slide is you will have a software bridge that's running on the machine, and the IP addresses that you get for your container are corresponding to the network that this bridge creates, right? So this is what you will get for your containers. The other one is that IP address is kind of not pingable from your outside the cluster or outside your machine, right? So if you want if you want to run some application as if it's running on the machine, on your direct machine itself, that is physical machine itself, you can use the host mode, where it will get a port in the physical machine's network space itself, and that can be accessible using the IP address of the host machine itself. We'll see that as well today. Both these things, the bridge network and host network, is what you will configure on your environments and see how the networking works, or what IP addresses your machine will get, or your container will get, right? So the default thing, if you would have done if config or IPA on your Docker container that you created in yesterday's session, you would have seen that you have a IP address assigned, right? Who gave you that IP address, and which network was that IP address for? So the default mode in which you get IP addresses in the Docker network is this bridge mode. So this is a default mode of networking in Docker containers. So you get your IP address in this bridge, the network, in the bridge network, right? So this is what was there, what you did yesterday, right? So you brought up Nginx Nginx container, and it got IP address. This was because of the Docker 0 network that got created because of the Docker bridge, right? Right. So how does this software bridge work, right? So we'll get into a bit detail on what exactly happens when a Docker network is created with using the bridge mode. So what happens is there is a Docker 0 bridge created. In fact, we'll see after we start off with some theory, we get you guys to see these interfaces on your machines as well. So what you have is a Docker 0 bridge created, and which connects to it 0. This is your physical machine or your laptop's interface, right? This is the laptop's interface that it connects to. And then for every new container that comes up, there is a vth pair that comes up. So what do you mean by vth pair is just a virtual cable that connects to ends, right? So here what it enables is, as we spoke yesterday, that every container will have its own network namespace, right? So any container that you created will have its network namespace, but Docker 0 is in the default namespace. So by default, when you have a Linux machine up, it has a namespace which is a default network namespace, right? So this Docker 0 and your it 0 are in your default network namespace, and your containers that you create are in their own network namespaces. For example, here it's NS1, right? So to help them communicate, like suppose one wants to communicate with 2, or one wants to communicate outside the network, outside your machine, it needs to at least get connected to this Docker 0 bridge, right? It needs to connect to other namespaces as well. So that's how we use the vth pair. That is, vth pair helps to connect. Here the two endpoints are the two network namespaces, right? So here you connect namespace 1 with the default namespace using this vth pair. So what gets created is a interface that gets created inside your container, and there is a corresponding endpoint on the Docker bridge which you'll see on your laptop or your host machine, right? We'll see these interfaces created as part of the hands-ons today, but this vth pair is what gets created, and it helps connecting your Docker container with each other or with outside the network, outside your machine. Right? Are we clear till now? Yeah. So we reach the point where we'll start and experience this vth pair and see how these interfaces are created. So do you guys have the Docker containers you created yesterday up or not? If not, you can use the first, by the way, the slides are shared on Slack, so you can download them in case for easy copy pasting of the commands. So in case you don't have the Docker containers up from yesterday, you can use this first command to create the Docker containers. Do we have a container up for everyone here now? Okay, so in case, yeah, we'll give you guys time to get it up, but in case some of you have the container up, just do IP link show there on inside. Okay, before doing that, just I don't know. Okay, so can you exec into your container in case it's not using the run command? Can you exec into the container using the container name, using this command? So everyone has the container up? Yes? So did you exec into the container? Yeah? Did you do IP link show? This command? Inside the container. So what did you guys see when you did IP link show? I want answers, guys.
There's two interfaces running on the Docker container.
Which are those?
Loopback and
Ethernet 0. And does it have an IP address?
Yeah, it does.
What's the IP address for it?
172.1.7.
Okay, great. So it has an interface created for you. Did you do something special for it to get that interface? No, right? So how did it get it? Using the Docker bridge network, right? So let's see what this corresponds to. What we saw in the earlier slide was that there is this pair created. So this it's 0 that you saw just now, as he said, that one had that 172 kind of IP is the endpoint inside the container which was created for the Docker network, right? So let's see on the other side the other endpoint of this this interface. So what we should do is not inside the container but outside on your VM on which the Docker is running, or your physical machine on your laptop where you have the Docker installed, that way, right? So on the physical machine or your laptop, just do IP link show there or ifconfig. So did you get any of you do ifconfig or IP link show on the host machine on which Docker was running? Right, so do you see, we said it's a veth pair. Do you see any veth interfaces there? How many interfaces do you see? Sorry, only one? Okay, because you have just one container running? Perfect, right? So that is the that is the interface. This is that is the other side of the with pair that is running on your physical machine, right? So if you want to really see if it is actually being used or not, what you can do is inside your Docker container, just try accessing the internet using a ping command, right? So in fact, if you want a specific, you want to keep the count of what number of packets being sent, what you can do is use ping -c 8888. It's just some IP address to access the internet. So what do you guys see here? If you do this from inside the container, just do it -c5. So it's like 5 ping requests will be sent to this IP address from inside your Docker container. Just run this command, and once you do that, raise your hands. Okay, awesome. So what you should do is now do if config inside your Docker container. Okay, so if you did ifconfig, what was the RX? There is a huge number of things printed, but there will be something printed after RX in terms of bytes, number of bytes that are RX. That means it will sent out, or sorry, TX. That is number of bytes that were sent out from your container. What's that value? Sorry? You got some number, right? So now what you should do is, on your physical machine where you just saw this interface running, just do ifconfig and check the value of TX again, that is the ifconfig again for this VH interface on your physical machine or your VM, if the Docker is, wherever the Docker is running. Are they matching? Right? So this shows that whatever packets you sent out from your container are using this V8 pair to access anything that's going out of the interface, right? So we see the V8 pair in action on your local setup itself using the Docker bridge, right? Everyone with me here? Okay, great. So now we saw something about how your container could got an IP, how it communicated with the outside world. Let's now see how these interfaces are what exactly goes inside the Docker. To do that, what you can do is do Docker network inspect bridge on your machine on which Docker is running, or let it be your laptop or your VM. So what did you guys see? It's a huge message printed. But do you see the IP address of your container somewhere there? Right? Right? So where is it? What's it says? Right? So that is the interface that's connected to the Docker bridge. Right? It clearly says that this is the IP address that's connected or created for inside the Docker bridge. Right? So this is just to give a feel that we verified that the V pair was created and that it's part of the Docker bridge network, right? So there are some things that we will skip in interest of time on this slide, but later if you want to just experience this, and if you, in case you have Wireshark, you can run and see Wireshark inside your container and see how the packets are going on, what are the headers added, in fact, all that stuff, right? So, and how they are communicating. In the interest of time, we'll just skip this today, but I suggest you guys to go back and try it out. Right? So, the other thing we want to test is, can you just do Docker network ls or list? What do you get when you do a network list? This needs to be done on your laptop or your VM where Docker is running, right? Do you see three networks created? One host, one none, one bridge, right? So this is what we saw initially when we started our day to day. There are three networks created by default, that is host, network and none. So what we saw till now, the IP address you got for your container was using the Docker bridge network, right? But what if you wanted your container to be using the host network that got created? What you can do is run this command, that is docker run network. What you have to specify here is, I don't want to use the default bridge network that gets created, but you need to create the host network that gets created. I want to use the host network instead for this container. And here you can just use Alpine. Instead of the Docker image that is specified here, just use Alpine and run this command. Okay, so do we have this Docker container up using the network host? Yeah, please raise your hand, guys, so that we have, wonderful, wonderful. So can you just do if config now inside the Docker container? Did you do that? What did you see? Same as? Same as the host, right? Earlier you just saw two interfaces. One was the local host and one was the H0. Now you see the entire interfaces that your host has inside the Docker container as well. This is because you have set it to use the host network itself, right? Okay, are we good till now? Okay, wonderful. So the next thing that we wanted to talk about is, whenever you create an application, like we created Nginx yesterday, right? You expose, when you created a pod yesterday, there was a port 80 that we had, container port 80 that we had created in the YML yesterday, right? So in a similar way, when you want to expose a port for your application, that can be done using the expose command to expose that particular port for that container, right? So what it basically does is, whenever you, if you don't expose that port, then the curl to that port won't work, right? In case you don't expose it, right? So that's the only way to say that, okay, this is the port that my container is ready to accept request in or request packets in, right? So there is another concept that happens here in Docker networking is published ports, which I think Kavya covered yesterday, where you say that I want this port open on your physical host for my container to connect to. I mean, for my container to be exposed outside the physical machine, right? So what I do is, I say that I want a host port to be open for my container port. That is, you exposed some certain port, let's say 80, what you did for Nginx, and I say I want something, suppose 7001 or something like that, some 7000 port on your physical machine exposed to be used by this container, right? So that is used using port mapping, or what is called as published ports, right? So what's the difference between expose and port is, expose just says that my container is ready to accept request or handle request on a particular port. But publish port says that this port should be accessible on the physical machine for someone from the outside my machine to get connected to it, right? So we can try this, but I think you guys did you guys do this yesterday? Did you run publish port yesterday? Right? So you guys ran this, so I think we can skip it. The only thing I want to emphasize is, in case you want to publish a port which just needs to be open inside your physical machine and not outside, external folks you don't want external folks to connect to it. All you have to do is specify the local host IP, that is 127.0.0.1, which specify that only apps running or processes running inside your machine can access this port and access this application that's running inside your container, right? So that's the only difference from what you guys did yesterday if you want to have a local access itself, right? So, okay. Okay, so the next part of the session now will be, now you got it very easily, right? You got the container, created the container, it got the IP, you could ping it, it would access the internet, everything was sorted for you. Now we'll see what exactly runs internally, right? There was a v8 pair that you saw that was created for you. Now what we'll do is, we'll ourselves create a v8 pair across namespaces and connect them and see how this Docker does it under the hood, right? So for that, what we'll do is, create two namespaces. I'll give you commands for this. Just see what your setup will be right now. We'll create two namespaces, namespace 1, namespace 2. Then we'll create two interfaces, that is virtual interfaces, that is E1 and E2. Then we'll add E1 to be part of the NS1 namespace. We'll add E2 to be part of the NS2 namespace, and then connect them and see that we are able to ping each other, these interfaces, across these namespaces, right? So that's the first task that we'll do as part of the session today. So what you should do right now is, the IP exposes some special tools to create your network namespace as well. This netns helps you create a network namespace, right? So can you add or create two network namespaces, that is NS1 and NS2, on your laptop or your VM where Docker is running? Right? Have you created the network?
So yeah, so guys, this is what I was talking about yesterday, right? So till now we were running containers. So in this slide, from this slide onwards, we are creating a network namespace manually, and for our interest, that is kind of a container, right? So we are skipping Docker, we are directly doing this stuff. So when you do IP netness add NS1, you're creating a new network namespace, and it is going to be empty actually. If you do the last two lines here, it is pretty much like a new container, right? And you're doing it directly instead of Docker doing it for you.
Okay, so as Chandra said, right, you can run this commands and see it's empty. Do you see that? Yeah? Okay. So now what we'll do, as we saw in this figure, we'll create these interfaces, right? So let's create the interfaces of these. Oh, okay. So is the V8 pair created for you with E1 and E2? Right, so yeah, in the host. Now we are not using Docker at all. From now on in this session, we are not creating any Docker containers, not using any Docker network. We'll create it on the physical machine. Yeah.
So exactly what I did was I exec a bash inside the network namespace. I exected bash inside the network namespace.
Okay.
So should I write this it outside the namespace?
Yeah, outside. We then later add it to the network namespace.
So what we're doing in this slide is we are first creating a V8, right? So V8 is like a cable. Think of it like one cable, right? So it has two ends. So first you're creating, the first line is you're trying to create that cable on your machine, on your host, right? It has two ends, E1, E2, right? So then the next two lines, what you're doing is you're moving the ends into the two different namespaces, right? And then once you've moved it, if you run the IP link command on your host, you should not be able to see it anymore. Those things would have gone because now they're inside the two different namespaces. So the last two lines, if you just, again, every time you do an exec ns1, ns2, that means you're trying to see how it looks inside the namespace or how it looks inside a container, right? So in the last two lines, you should see that those two ends are gone inside those two containers. That's what we're doing here manually, right? You can think in reality, Docker may be doing something like this underneath, but this is what we're doing manually.
Right, so once you create this V8 pair, you assign the endpoints of these V8 pair to the individual namespaces here, and then you can see them added as part inside the network namespaces using these commands. Just to confirm that these got added correctly into the individual network namespaces. That is, ith1 got added to ns1 and ith2 got added to ns2 namespace, network namespace. So are you seeing E1 and E2 in your network namespaces NS1 and NS2? Yeah? Great. Right, so now as we said, you want to able to see if they can connect with each other, right? So we would add IP addresses to these interfaces. So this command will add IP addresses to the devices that got created, that is E1 and E2, that is the V8 endpoints. You'll get the addresses added so that we can ping each other and see if they are connected, right? So what this will do is add the IP address, and you can confirm the IP address using these commands. This is just to confirm that it's working. Then you have to get these interfaces up using these commands and then exec into these network namespaces. Like just do this here and then let's see. So what do you guys do see when you run this command? So you see the IPs, right? Yeah. So let's see if they get connected. Do you just run this and see if this works now? Back. Okay. Let's hold out for few minutes.
कमांड पे वी आर क्रिएटिंग द वेज पेयर
हाँ
सो पेयर करके वो कमांड है ना उसके बाद नेम लिखना होगा वरना E2 बनेगा ही नहीं
पेयर E2 लिखा है
पेयर नेम E2 होना चाहिए
पर इनका बन गया है एक्चुअली
इन लोग का नहीं बन रहा
इनका नहीं बन रहा है क्या Are people able to connect the V8 banner? Some people I think the command is changed that V8 peer name E2 is it?
Okay.
Should I tell?
I'm seeing
It's
V8.
working, right? Okay. Hi guys. Is anyone facing issue getting this command running? Please raise your hands. Okay, I think yours got fixed, right? Now with Alvin. Right, rest are able to get this up, right? So are we done here? Please raise your hands if you're done with commands on this slide. Great. So what I'll ask you to do is, now that you had assigned the IP addresses here, right? Let's see if they are able to connect to each other. Just run this ping command here from network namespace 1 to connect to network namespace 2. Are you able to ping? No, right? Because you need to add a route to say that this with pair needs to be used for this packet to go out, right? So what we'll do is add a route on both the namespaces, that is NS1 and NS2, saying that you get this IP address for you use this IP where whatever you want to connect to outside, using this IP address, it has to go out from the E1 device that got created for NS1. Similarly, device E2 for NS2, right? Right, so once you get these commands running, confirm that the route got added correctly using this IP route command on both the namespaces to see that the route was set correctly for this IP addresses for the individual network namespaces. And once you see the routes being added correctly, now try the ping. Now it's working? Yeah. Okay, so we did this exercise just to experience what are the challenges or what number of steps you have to do just to get to network namespaces connected, right? So imagine if we did not have Docker, we had to do it all manually each time we wanted to create a network container and connect them, right? So this is just to appreciate what Docker does for us under the hood, right? In terms of networking and to understand how basically it does it, right? So it creates the interfaces, creates the VH pair, adds them to the namespaces, assigns IPs to them, assigns the routes to them so that they can get connected, right? So there are a lot of steps that Docker handles to connect these containers.
So what have we done in this talk, right? Like this portion. So what have we done? We have run two containers and we have connected them and we have manually kind of set up the networking between them, right? So you can see there are a few aspects here. One is there is an L2 device, right? That's the VH pair. That's the actual Ethernet or virtual Ethernet in this case. And then there is the L3, which is the IP. That's when you added the IP, right? You actually gave each of those containers an IP. And then finally there is a routing aspect, right? Where you're telling each of the containers how to route to the other container, right? So there are actually these three dimensions that you need to do before two containers can talk to each other, right? But this is the most like basic combination you have done. You have manually done everything and it's for just two containers, right? You actually physically connected those two containers with a wire. That's what you've done, right? But this doesn't obviously scale, right? You can't do this to connect hundreds and thousands of containers. So the next thing that we will show, this is the commands to clean up, you can run this. But the next thing we'll show is closer to what Docker is doing, right? That is actually have a bridge device and then connect a number of containers to that bridge device, right? And then let that bridge take care of the routing for it, right? So this is one step closer to how it will actually work in reality, right? But we are still, in this case, we are still manually creating the internet, Ethernet devices and adding the IPs, but at least one step closer to the end.
Right. So before we use a bridge network, I'll ask you guys just to delete the network namespaces that you created, so that we can create a bridge and help them connect again, right? Right, so once you've deleted the network namespaces, as Chandra said, right, we just till now we just created one eth pair and got it connected, right? So it's okay if you just want to connect your Docker bridge or you want to connect just two containers, right? But for in your machine itself, you can have 10 or more than 10 based on your resources number of containers. So you want to connect them all together, right? So we'll actually see how the default mode that we discussed today, right? What the default mode of bridge, how that can be used to create the network namespaces, to create the communication between these containers that are part of different network namespaces, right? So we'll use the same kind of conventions, that is, we'll create two network namespaces that is assuming that each of our containers run on these individual network namespaces. As earlier, this is not over Docker, this is on your physical machine, because we are just trying to get a feel of what Docker does when it creates a bridge and how does it connect using the bridge, right? So we'll create two network namespaces, create a bridge, that is this NSB will be our software bridge that gets created on your machine, and we'll create two with pair, that is one endpoint of each of these with pair will be on the bridge and the other will be inside the network namespace, as we saw earlier, right? The ith0 was inside the container, the bridge one was, the vith was on the Docker bridge, right, on the physical machine. So similar to that, we'll create our even b1 to connect ns1, that is suppose see container 1 running here, or similarly for ns2, b2, e2, assuming container 2 is running here, right? So we are not creating the containers, we just want to show that your containers will be using different network namespaces, right? So as earlier, we create two network namespaces and just confirm that they don't have any interfaces up right now or added to it, right? And here the link, as Chanda mentioned, that the link implies that you want to see if there is any L2 device that's created, right? These even E2 here are and even V2 are L2 layer interfaces or virtual interfaces, right? So just this IP link will help us confirm that there is no L2 device added yet. Yeah, so we are up. Are these commands running again? Okay, so next thing we do is, as we had it in this diagram, we create the NSB bridge, right? So NSB is the name of the bridge, and this bridge defines, this is the type of what we want to add, right? So, right, create the bridge and bring the bridge up. Yeah, is the bridge up for anyone? Yeah, great. So next what we do is, as we had it in the diagram, we create with pairs again, right? So last time when we did a peer-to-peer, that is connected a namespace directly to NS1 to directly to NS2, we created it E1 and E2 and directly connected it. Here, but what we'll have is, we have the bridge NSB where we'll have B1 and that we'll have later. What we first create is two V8 pairs, that is E1 connected to B1 and E2 connected to B2. So this two just create the Vth pair that's required. Are the Vth pair created? So once the Vth pair is connected, as last time, we add these endpoints to the individual namespaces or bridge, right? So what we do is, E1 gets added to NS1, E2 gets added to NS2, right? The Vth endpoint of one endpoint of each of these Vth pairs get added to individual namespaces. Similarly, this endpoint, that is the B1, B2 of the other endpoint of the V8 that got created, we add them to the bridge. Right? So are your V8 pair created? The endpoints of both of the V8 pairs added either to NS1, that is E1 added to NS1, E2 added to NS2, and B1 and B2 added to the bridge. Right? Please raise your hands if you've done with that steps. Okay, great. So what we'll now do is, as again, we'll add IP addresses to these interfaces, right? So these, again, we'll add the IP addresses of 0.192.168.0.1 to E1 and 0.2 to E2 again. And just confirm that the addresses got added correctly. So as Chandra said last time, right, we created the L2 interfaces, that is the V8 interfaces. Now we are adding the L3 layer for it, that is we are adding the IP addresses for it, and this step. So are we done with the IP addresses? If yes, then we just set these interfaces up. Right, so if the interfaces are up, we set the other interfaces of the V8 pair, that is B1, B2 also up. Are both E1, E2 and B1, B2 up for everyone? Again, show of hands, please. Okay, we'll wait for just a moment.
Yeah, very much no time. Exactly. Good, actually. We can end early, have tea, and then start the next one early. I did not expect you. You did a very good job with it. Yeah, thanks. Mast kiya ye. So I'm very comfortable. Looks like, right? I'm very happy today. First session which we're doing, very very happy also when to see like some people like that. So to see when transfer to match to very excited. Nice. Good session.
Okay, so if all your E1, E2, B1, B2, all the endpoints, V8 pairs are up, now we have to add, as last time, we have to add routes to tell that what we have to get packets out of E1 and E2, that is whenever this IP address is used. right? So can you add that and check as last time that the route got added correctly? Are the routes added for everyone? Show of hands if routes are added. Great. So what we'll do now is, as last time, try pinging the 190 to 168 0.2, that belongs to NS2 from NS1, and check if the ping is working. Is it working for anyone? No? Sorry. Packet loss? Okay. Did you add the routes here? Okay. Did you do B1, B2 up? Can you check what is the output of IP link then? It's working for you? Okay. So what we did was E1, E2 up in individual namespaces, then B1 up and B2 up, then add these IP addresses, add the routes for NS1 and NS2, individual E1, E2. Can you check the routes if the routes are added correctly in NS1 and NS2?
That side is facing, ping is not working for me.
Sorry?
That side ping is not working for me.
You had added BS1 and B1 and B2 to NSB, right? To the bridge.
Ping is not working. Someone I have a doubt. So B1 B2 को कुछ करना पड़ेगा क्या? नहीं ना? हाँ, that's why. Then that person worked apparently.
Okay. Some different people facing different things, so I'm just going out.
Okay, I'll also then go now. हाँ रिंकू, नहीं चला? क्या हो रहा है? मतलब B1 B2 IP लिंक किया तो क्या दिख रहा है?
IP लिंक नहीं किया मैंने. I think ये ना IP लिंक.
हाँ. NSB created है. B1
अब तो दिखा रहा है. अब तो है.
ये दोनों इंटरफेसेस अब तो है.
बट ये नो कैरियर क्यों दिखा रहा है?
वो डॉकर 0 तो वैसे भी यूज़ नहीं कर रहे हैं, तो वो ठीक है, चलेगा.
तो आप ही है.
तो फिर आइडियली चलना चाहिए था. E1 E2 को राउट ऐड किया, E1 E2 को IP एड्रेस ऐड किया, B1 B2 NSB को ऐड किया.
हाँ. सब एडेड है.
नहीं, कमांड से चले थे एक्चुअली, तो
कुछ एड्रेस में कोई गलती कहीं पे करती है क्या?
पर सब बहुत लोगों का नहीं चल रहा है, एक बार मैं चेक करती हूँ। एक का चला मुझे,
चला।
हाँ मुझे डाउट हो रहा है कि उसका चला है कि नहीं, कि उसका पहले वाला ही चला है, वो वही बोल रही है। मुझे भी थोड़ा डाउट हो रहा है, मैं ज़रा नीचे चेक करती हूँ। So is the ping working for anyone? Okay, now it's a mixed bag. We'll come around. चल रहा है क्या? राउट ऐड हुआ? हाँ। बता सकते हो आईपी एड्रेस करके? E1 हाँ। राउट इज एट। हाँ। B1 B2 कनेक्टेड, आईपी लिंक करके देखो। B1 B2। ओके। आइडियली मुझे लग रहा है कहीं कोई कर्नल वर्जन का इशू हो रहा है, बिकॉज ये कमांड्स हमारे लिए तो चले थे। हाँ, हमारा एक्चुअली कर्नल जरा पुराना वाला है, उसमें है तो शायद चलना है। इज इट अ कर्नल इशू?
Different people are in different states. For some people, the device is not up. For some people,
For
the device is up.
like Rinku device is up, these guys' device is up.
But ping is still not.
हाँ,
For
ping
some
is.
people, everything is working.
हाँ, how come it's up?
Kernel version.
Yeah.
Everything is correct, but it's in down.
Down लिए.
हाँ.
Even if you did up किया तो भी.
I did up again.
NS भी up किया, B1 B2 भी up किया, E1 E2 भी up किया था।
नहीं वो करती मैं।
हाँ, NS E1 E2 पहले मतलब नेम स्पेस में एग्जैक्ट नेम स्पेस में कमांड है एक्चुअली इसके पहले वाले इसमें। E1 E2 को अप करना है, B1 B2 को अप करना है, E1 E2 को आईपी एड्रेसेस डालना है, फिर राउट डालना है NS और यहाँ, और फिर पिंग ट्राई करना है। अलग अलग लोग अलग अलग जगह पे शक कर रहे हैं, पता नहीं चल रहा है कि क्या गड़बड़ है।
ऑर्डर तो सही है,
हाँ।
मैं देख रही हूँ गड़बड़ प्रॉपर लाइक
हाँ,
गड़बड़
लग नहीं रही है, वही तो मतलब नहीं, वो चला था ना हमारे, और थोड़े लोगों के लिए चल रहा है, थोड़े लोगों के लिए नहीं चल रहा है। हाँ चल रहा है, मतलब 5 लोगों के लिए चल गया एक्चुअली।
तो डिफरेंस क्या है?
मेरे को लग रहा है कर्नल वर्जन में ओ, मुझे इसमें तो बहुत उनका नहीं है एक्चुअली, वही तो समझ में नहीं आ रहा है।
इसे लाइक जो कॉपी पेस्ट कर रहे हैं उनका नहीं चल रहा, जो टाइप कर रहे हैं उनका चल रहा है, ऐसा कुछ होगा तो हो सकता है किसी ने।
अरे पर इसमें कुछ हाइफन वाइफन भी नहीं है ना, आई मीन इट्स स्टिल
जिनका चल रहा है
हाँ।
उन्होंने कुछ लॉजिकली लिखा है, कोई एक कहीं कोई या तो आईपी या तो नेम स्पेस का नाम में कुछ गड़बड़ नहीं है ना,
नहीं तो
पेस्ट करा।
अरे कमांड तो चली तो वही कॉपी पेस्ट करके हमने भी स्लाइड्स में डाले हैं, तो उसमें कुछ चेंज तो नहीं होना चाहिए था एक्चुअली।
कमांड ठीक भी लग रहा है।
हाँ हाँ अप है ना, नहीं थोड़े लोगों के लिए अप भी नहीं हो रहा, पता नहीं सेम कमांड चलाने पे अप भी नहीं हो रहा है, तो ऐसा अलग अलग स्टेजेस पे अटके अपेरेंटली लोग। शायद यार ये हो जाता तो काम सही था। ये लास्ट पार्ट है इसका, ये वाली सेशन का एक्चुअली।
बहुत लोग इस पे अटके हैं क्या एंड में?
हाँ लोगों का सब, बहुत लोगों का अप है और तो भी नहीं चल रहा है। एक बार उल्टा ट्राई करके देख, NS2 से
मैंने वो भी किया,
नहीं चल रहा,
वो भी नहीं चला, और मैंने ये भी ट्राई किया कि इसको ट्राई करो, खुद को तो चलना चाहिए,
वो भी नहीं चल रहा है ना,
वो भी नहीं चला, खुद को तो एटलीस्ट चलना चाहिए था, 2 को नहीं चला तो 1 के साथ, खुद के साथ क्यों नहीं चल रहा?
हाँ यार खुद को क्यों नहीं चल रहा है,
तो वो मुझे समझ नहीं आया कि वो क्यों नहीं चल रहा है।
पहली बार में तो अच्छा पहली बार में हमने ट्राई नहीं किया था ना, जब अपने वीथ वाला करके तभी भी ये इंटरफेसेस अप किए ही थे ना, खुद का तो चलना ही चाहिए था एक्चुअली। नहीं नहीं, खुद का नहीं चलेगा, राउट ऐड ही नहीं किया है वो। ये नेम्स पे सेल्फ वाला बाय डिफॉल्ट रहता नहीं है ना शायद से इसमें। सेल्फ आइडियली होना चाहिए, होना चाहिए।
अगर NS2 से NS2 से G, लेकिन एक साइड से नहीं होगा तो दूसरे साइड से Q ही होगा।
एक काम करना, मतलब आई डोंट देखो बोल सकती हूँ मैं, ये आईपी जरा चेंज करके देखना। मेरे को लग रहा है ये कुछ डिलीट नहीं हुआ है, कुछ गड़बड़ हो गया है। नहीं, मुझे लग रहा है 3 और 4 कर दे, 1 और 2 की जगह पर 3 और 4 कर दे, 0.3 और 0.4। अगर वो चल जाए ना तो मैं वैसे बोल दूंगी बच्चों को।
ओके, पहले वो डिलीट करनी पड़ेगी ना वो।
हाँ, मैं कमांड दूँ क्या?
नहीं मैं
हाँ
मैं कर ट्राई करूँ।
हाँ
हमने
मैम
हो गया।
क्या क्या क्या
क्या किया अलग?
पूरा फिर से क्या, इट्स जस्ट वो जो आईपी है ये नहीं, जब मैं आईपी ऐड कर रहा था इंटरफेस में तो मैंने सबनेट दिया /16 का।
/16 का तब चल गया। ओके, आई विल टेल दैट देन, थैंक्स। Okay, I think for some guys the interfaces came up but the ping was still not working. I think one of our guys debugged it. The issue was that when you added this IP, you need to give the subnet as /16 here. So what I'll recommend for guys for whom the interfaces were all up and still the ping was not working, just please delete these interfaces. Delete the namespaces and please try adding following these steps again, but this time adding the IP addresses with /16, like adding the subnet also to the IP address. So I think bridge doesn't have to be created again, or the B1, B2 don't have to be created. Delete the namespaces and just do these commands. Once you delete the interface namespaces using these commands, that is delete NS1, delete NS2, then follow these commands, that is set E1 and E2 to NS1 and NS2, right? Once you do that, I'll wait for some time. Just delete and create first, that is add namespace 1 and namespace 2. So folks facing the issue, did you delete the namespaces? Right? Then add the namespaces again. Once the namespaces are added, follow this 2 steps here to add E1 and E2 to this NS1 and NS2. Once you add E1 and E2 back to NS1 and NS2, add addresses for these devices E1 and E2 again here, but make sure this, just don't do 192.168.0.1, use 192.168.0.1/16 for E1, and for E2 use 192.168.0.2/16. Let's /16 is important, right? So once that is done, up the interfaces again, E1 and E2. Once that is done, that is once you add the IP addresses, set these interfaces up, that is even and E to up, just go and re-add the route. Here also, you have to make sure you use 192.168.0.1/16, and for here, when you add the route as well.
It doesn't allow
/16, okay, just to. It's pinging now? Still not pinging for you? Try different IP addresses. Instead of 0.1 and 0.2, try 0.3 and 0.4. Once you add the routes, please try the ping again. What we wanted to show you guys was it's tough to handle all this on your own, and I think you guys saw it yourself. So the whole purpose was all this gets handled for you by the Docker network itself without you worrying about it. So appreciate it, and we'll see what gets handled for you in Kubernetes when things get more complex when you move across machines in the next session.